Welcome to this lesson on roots of quadratic equations. We will learn how to solve quadratic equations using the quadratic formula and understand what the roots tell us about the graph. Before we begin, make sure you are comfortable with solving quadratic equations using the quadratic form. Whenever we have quadratic equation in the form ax squared plus bx plus c is equal to 0, so we can use this formula to find out the roots of the equation. Let's solve an example. In this, we have x squared plus 4x plus 4 is equal to 0. We can write down the values of a, b, and c. A is the coefficient of x squared, which is here 1. B is the coefficient of x, which is 4 here, and C is the constant term, which is 4 in this case. Then we will substitute the values of A, B, and C in the quadratic formula. So we have here x is equal to minus B means minus 4 plus minus under root B square, which is 4 square, minus 4ac, 4 into a is 1 and c is 4, divided by 2 into 1. When we'll simplify it, we will get minus 4 plus minus under root 16 minus 16. Divided by 2. When we'll simplify it, we will get minus 4 plus minus under root 0 divided by 2. So x is equal to minus 4 upon 2. X is equal to minus 2. Here, the value of b square minus 4ac is 0. So we have got two equal roots. Or we can say just one root. Let's do another example. X squared plus 9x plus 1 is equal to 0. A is 1, B is 9, and C is also 1. Now we'll substitute the values of A, B, and C in quadratic formula. X is equal to minus B means minus 9 plus minus under root B square, which is 9 square, minus 4 into A is 1 and C is also 1. Divided by 2 into 1. Now we have x is equal to minus 9 plus minus under root 81 minus 4 divided by 2. And we'll simplify it further. We will get minus 9 plus minus under root 77 upon 2. We can write x is equal to minus 9 plus under root 77 divided by 2, or x is equal to minus 9 minus under root 77 upon 2. So here the value of b square minus 4ac is greater than 0. So we have got two distinct roots. Let's do another example in which we have x square minus 3x plus 15 is equal to 0. A is equal to 1. B is equal to minus 3 and C is equal to 15. We'll substitute these values in quadratic formula. So x is equal to minus into minus 3 plus minus under root b square minus 3 square minus 4 into a into c, which is 50, divided by 2 into 1. When we'll simplify it further, we will get minus minus will become 3 plus minus under root nine minus 4 into 15, it is 60, divided by 2. Then we have 3 plus minus under root minus 51 upon 2. We cannot simplify it further because there is negative number within this under root sign. We can say that there are no real roots. Now we'll discuss about b square minus 4ac and how it affects the roots of the equation. B square minus 4ac is called discriminant. When b square minus 4ac is greater than 0, then roots are real and distinct roots. When b square minus 4ac is equal to 0, then there are two real and equal roots. When b square minus 4ac is less than 0, then there are 0 real roots. Or we can say no real roots. Now we will see how the roots of the equation are connected with the corresponding curve. Whenever b square minus 4ac is greater than 0, means positive, then there are two real distinct roots and the shape of the curve is either it opens upward or it opens downward. The curve cuts the x-axis at two distinct points. So you can see it's intersecting the x-axis at two different points. In this case, the coefficient of x square is positive, and in this case, the coefficient of x square is negative, and here it intersects the x-axis at two distinct points. If b square minus 4ac is equal to 0, then there are two real equal roots. And if the coefficient of x squared is positive, the shape of the curve is to be like this, open upwards, and the graph intersects the x-axis at one point. In this case, the coefficient of x squared is negative, so the graph is opening downwards and it is intersecting the x-axis at one point. So whenever b square minus 4ac is equal to 0, then there are two real equal roots and the curve cuts the x-axis at one point. When b square minus 4ac is less than 0, means negative, then there are no real roots. In this case, the curve is entirely above or entirely below the x-axis. When the coefficient of x squared is positive, then the curve is to be above the x-axis. And if the coefficient of x squared is negative, then the curve is to be below the x-axis. Now we will apply b squared minus 4ac to quadratic equations where there are unknown constants. So we can use b squared minus 4ac to find out the value of unknown constants in the given quadratic equation. Let's do some questions related to this. Find the values of k for which k plus 1 x squared plus kx minus 2k is equal to 0 has two equal roots. You have to find the values of k for which k plus 1 x squared plus kx minus 2k is equal to 0. You can see this is a quadratic equation. Has two equal roots. You have to look for the keywords. Here it says two equal roots. When do we get two equal roots? When we have b squared minus 4ac is equal to 0. So it means that we have to apply b squared minus 4ac discriminant to find out the values of k. Let's take out the values of a, b, and c. The value of a is k plus 1, the coefficient of x squared. The value of b is k, and c is minus 2. As we have to take out the values of k, we can just use b squared minus 4ac is equal to 0 to take out the values. We have here b squared means first of all, we will write b squared minus 4ac is equal to 0. b is k, k whole square minus 4 into a, which is k plus 1, into c, which is minus 2k, is equal to 0. Now we have k square minus, we have to multiply minus 4 by k and then by minus 2k. So minus 4 multiplied by k is minus 4k. And when you will multiply minus 4k by minus 2k, you will get 8k square. Then you will multiply minus 4 by 1 and then by minus 2k. Minus 4 multiplied by 1 is minus 4. Then multiplied by minus 2k will be plus 8k. Now we have 9k square plus 8k is equal to 0. We can take k as common. So we will be left with 9k plus 8 is equal to 0. We have k is equal to 0 and 9k plus 8 is equal to 0. Then k is equal to minus 8 upon 9. So the values of k for which you will get two real equal roots are 0 and minus 8 upon 9. Let's do another question. Find the values of k for which kx squared plus 2 into k plus 3x plus k is equal to 0 has two distinct roots. We have to find out the values of k in the given quadratic equation, which has two distinct roots. If there are two distinct roots, then b square minus 4ac is greater than 0. So first of all, we will write down the values of a, b, and c. A is equal to k, the coefficient of x squared. B is equal to 2 multiplied by k plus 3, which is the coefficient of x. And c is equal to k, which is constant term. Now we can substitute these values in b squared minus 4ac is greater than 0. So b squared is 2 into k plus 3 whole square minus 4 into k into k greater than 0. Then we'll have 2k plus 6 whole square minus 4k square is greater than 0. As we have 2k plus 6 whole square, so we have to apply here identity. A plus b whole square is equal to a square plus 2ab plus b square. So the first term is a square. Here a is 2k, so 2k square plus 2ab, 2 into 2k into 6 plus 6 square, b square minus 4k square is greater than 0. We have here 4k square plus 24k plus 36 minus 4k square is greater than 0. So 4k square and minus 4k square is to be cancelled out. So we are left with 24k plus 36 is greater than 0. We will take 36 on other side, so it will be minus 36. So k is greater than minus 36 upon 24, which is finally k is greater than minus 3 upon 2. So the values of k for which this quadratic equation has two distinct roots are greater than minus 3 upon 2. Let's do a past paper question. Find the set of values of k for which the curve 2x squared plus kx plus 2k minus 6 is equal to 0 lies above the x-axis for all values of x. We have to find the set of values of k for which the curve lies above the x-axis. Whenever the curve lies above the x-axis, then b square minus 4ac is less than 0. So in this case, we will use b square minus 4ac is less than 0. First of all, we will take out the values of a, b, and c from the given quadratic equation. we have a is equal to 2, b is equal to k, and c is equal to 2k minus 6. All the terms which do not have x are considered to be as constant term. Now we'll substitute these values in b square minus 4ac is less than 0, k square minus 4 into a into c, which is 2k minus 6, is less than 0. We have k square minus 4 into 2 into 2k will be 16k minus 16k minus 4 multiplied by 2 multiplied by minus 6 is plus 48 is less than 0. Now we have got here quadratic inequality, and we have already done how to solve quadratic inequality. So we'll be using the same method to solve quadratic inequality. First of all, we will factorize this using middle term breaking. So we have k square, factors of 48, which will give the result as minus 16 are 12 and 4. As we have minus sign here, so we will have minus 12k minus 4k plus 48 less than 0. We'll take k as common, k minus 12, minus 4 is common, k minus 12 is less than 0. Then we have k minus 4, k minus 12 less than 0. After that, we take out roots. So k minus 4 is equal to 0 and k minus 12 is equal to 0. K is equal to 4 and k is equal to 12. Then we sketch the curve and then write down the solution. We'll consider 4 here. We'll consider 12 here. As the coefficient of k square is positive, so the curve is to be a minimum curve. As the sign here is less than 0, so we have to consider the part of the curve which is below the x-axis, which means the values of x lies in between 4 and 12. So these are the values of x which satisfies this inequality. So we can write the solution set as k is greater than 4 and less than 12. So the set of values of k for which the curve lies above the x-axis are greater than 4 and less than 12.